Man, chemistry is so easy, but I just didn't get this substance and mixture unit. I'm gonna fail the Regents now. No, you won't.
Who said that?
Will Nye said that.
Will Nye?
I am Will Nye, the science guy.
Whoa! I'm here today to tell you everything you need to know about substances, elements, compounds, mixtures, and how to separate mixtures.
Wow, that's amazing. So my first question is, what's the difference between a substance and a mixture?
So you see, a substance has only one thing present. This includes elements and compounds. Elements are made up of one specific type of atoms and cannot be broken down by chemical reactions. When compounds are two or more different elements combined that are bonded chemically.
Wow.
Now, a mixture is two or more pure substances that are not chemically but physically combined. There are two main types of mixtures. One is heterogeneous. You can see the different parts of this mixture, and they do not have a uniform composition of properties. Whereas with a homogeneous mixture, you cannot see the different parts of the mixture, and they have a uniform composition. This is because a homogeneous mixture has a solute dissolved in it, unlike a heterogeneous mixture, which may have solids in it. This is how heterogeneous mixtures can have multiple phases, when homogeneous mixtures can only be in one phase.
Thanks, Bill Nye. Truly amazing. But how can one separate these mixtures?
Let's start with heterogeneous mixtures. There are many ways you can separate these mixtures. One of the common known ways is filtration. This is one of the ways we're going to focus on today, and this is when you add a medium where only the liquid can go through, leaving the solids in the mixture behind on the paper, separating them. Another way is using a separatory funnel to separate oil and water. A third way would be using magnetism. This is when you use a magnet to extract magnetic solids in a mixture to separate it from the substance it is in.
Wow, that's so cool. But how could one separate a homogeneous mixture? Is it even possible?
Oh, it is possible. So you see, the components in a mixture retain their own chemical properties. So we use these properties in order to separate them. One way is evaporation. Let's say we have a mixture of salt and water. If you add enough heat to it, the water will evaporate, leaving the salt behind because salt can't evaporate. This could be used for sand and sugar as well. Removing the chlorophyll pigment from leaves can be done with chromatography. Another way, of course, would be distillation. This is when you separate different liquids by using their different boiling points. It allows you to heat the mixture, and the liquid with the lower boiling point will evaporate, and then is cooled to condense back into a liquid, leaving two separate liquids. This method is commonly used to separate water from alcohol.
Thanks, Will Nye. That makes a lot of sense.
Now, I shall demonstrate two types of separating methods for you. One will be a heterogeneous method, filtration, and the other will be a homogeneous method, evaporation.
Truly amazing.
Whoa! So here I have these coffee solids, a glass of water, an empty jar, and the paper towel I will use as filter paper. First, I shall mix the coffee solids into the glass of water to create a heterogeneous mixture. So I will do that now. As you can see, there are solids in this mixture. Therefore, it is heterogeneous. Next, I'll put this filter paper over the cup. This paper will act as a medium that will only let the water go through and not the sand, because the sand is solid. Now I shall pour this heterogeneous mixture over the filter, and let's observe what happens. As you can see, only the water is going through, and the solids that are the coffee solids are being left behind on top of the filter paper. Only water can be seen, and the solids from the coffee are on top of the filter paper. Only liquid can go through, and not the solids. And there we have it. Only the coffee solids are left on the paper, and only the water can be seen in the jar. We have just separated a heterogeneous mixture.
Wow, that is really fascinating.
Now it is time to separate a homogeneous mixture.
I can't wait.
Well, actually, you have to wait. Evaporation takes a while, but I'll take a video of it, speed it up, and explain it to you afterwards.
Alright. So here I have this mixture of water and sugar. It is homogeneous as the sugar is completely dissolved in the water, and we cannot see it. It is only a liquid, no solids. So here I'm heating this up. The water is boiling and evaporating, and soon the water will all be gone, leaving the sugar behind, as sugar cannot evaporate. And here it is. This is the sugar that was just in that homogeneous mixture where we couldn't even see the sugar. We have just separated a homogeneous mixture. Amazing, Will Nye. That was worth the wait. And since you're here, can you help me out with stoichiometry?
Well, I'm out. Thanks for watching.